Hi, Shuan. Is that how I pronounce your name? Mm, uh, what is this the name you registered? They use to register for the class? Cause I don't see you on the attendance list. Okay, maybe we just start the lesson first. Okay, so if possible, can you turn on your cameras? So I'll be going through experimental camp today. Can I check if all of you have watched the relevant lesson and done the Okay, please turn on your cameras if possible. Today we are going through experimental camp. Can I check if all of you have watched the relevant lecture video and attempted the worksheet already? Okay. Can I check who has done the worksheet and watched the video? Okay. Um, Sure, can I check with you if this is the name you registered under? Because I don't see you in the attendance list. Do you have a, do you use an English name to register or something? Ah, okay. Okay, so I will give those of you who didn't do the worksheet some time to do during the lesson. Okay, so let's quickly begin. Okay, so today we are learning about experimental chemistry, which is about the apparatus in the lab and how we do experiments, the experimental techniques, right? Okay, so for question one, I'll give you a few minutes to do. Then once you are done, please enter your answer into the chat. Okay, any other answers? Okay, so those who said A are correct, right? This answer is A because gas syringe is to measure gas. Okay, and then for beaker is usually not very accurate. So it definitely cannot measure up to 0.01 or 0.1 cm cube. So typically beaker is less accurate than a measuring cylinder, so we won't use it to measure. Okay, so for pipette is used to measure fixed volumes. So I'm not sure whether you have seen it in your school lab, but usually pipette have capacity of like 20 or 25 cm cube. So there is no pipette that is specifically used to measure 23.80 cm cube. Okay, so moving on to the next question. You can try this question, then key in your answer again. Okay, so if at any point you have any questions, just type in the chat also. Okay, so the question is, which of the following set of apparatus is most appropriate to separate a mixture of insoluble calcium carbonate and water? So the key word here is that the calcium carbonate is insoluble, right? So this one is a solid and water is a liquid. So to separate a mixture of solid and liquid, what can we use? So if we look at A, separating funnel. If you all have seen it before, it actually looks something like this, right? With a tab here. So this one, separating funnel is used to separate two immiscible liquids. So immiscible liquids refer to liquids that do not dissolve in each other. So for example, water and oil can be separated using this kind of setup. Okay, then for chromatography paper, this one is to carry out chromatography. So this is not for separating mixture of solid and liquid. Okay, burette and conical flask. Burette is to measure things, right? It's not for separation techniques. So we will use the filter funnel to separate liquid. So it looks like this. Our filter funnel is here, and then the filter paper is over here. Then we will pour the mixture of insoluble calcium carbonate and water here. So only the water will flow through over here. So the answer is D. Okay. Please try the third question. Which of the following properties can be used to determine if a sample of sodium carbonate is pure? How do we determine purity? Pure means that it is not a mixture of two different things. There is no like impurity mixed inside. Okay, so most of you got the right answer is C. So to determine the purity, we always use either the melting point or boiling point. So what we do is we check if the sample melts or boils at a constant temperature. So if it is impure, it will melt or boil over a range of temperatures. Okay, so now fourth question, which of the following is always true for a pure substance? Okay, so this one should be quite easy since we just went through. Any answers for question 4? Any other answers? Yes, it can also be a compound, like water is a compound.